So, hello, welcome everybody to the late afternoon session. We are now in the RDA data discovery interest group, and this session will be about the data discovery AI and about experiences coming from the recommendations we published recently and AI challenges. The session chairs are here is Brigitte Mathiak here in front. Fotis from Greece, he's not with us today. Uwe Schindler is my name, and Mingfang is also sitting there. And let's start. So the first thing is the acknowledgement of the country. We acknowledge and celebrate the first Australians on whose traditional lands we meet, and we pay our respect to the elders past and present. So the collaborative notes, just scan the barcode, open them, and if you have any questions or something like that, you can write it down there. We will do that in the discussion round, which will be at the end after the presentations. But if there's something really urgent, you can of course also interrupt us. The agenda today will be, there will be an introduction now, which is done by Mingfang. And after that, we will have lightning talks, 3 in total. One is about similar dataset recommendations. This was requested on the last session in the spring this year to get some internals how to best implement recommendations. And then we have 2 sessions about how the 10 principles were adopted. One talk is done by myself for Pangea, and the other one is done by Brigitte for the GESIS. And after that, we will have the group discussion and the follow-up questions. So I hand over now to Mingfang.
Thank you. Excuse me. Welcome, everyone. I just give a brief introduction what this interest group is doing and how we organize our work. So this interest group especially focused on the fundability of data. We have a fair principles. The first one is to make data findable. But that's not enough, and these principles are more from repository perspective. We need to remember who is going to find the data. So the users is also matters, is another equation of this fundability. For example, the FAIR principles. This screen is small. That is. How about I use this one? So sorry, I use this one. How to make this switch? Hello, can you hear me now? Excellent. I use this one now, so I can see here. So FAIR principles say the metadata need to assign the unique identifier, but that does not ensure metadata content is relevant and complete to user's specific query. And FAIR data principle did say data need to describe with rich metadata. However, even you metadata there, what the interface will be like enabled for user to understand what metadata they are, how they can search to get a relevant data set. So, this group is particularly focused on from user-centric view, how to discover data. And we need to remember when user discover data, this activity is embedded in their overall research ecosystem. They come to search for data with, with the research need, special needs, and they may search data from their domain or from other domain, come different knowledge and terminology for that data set. And the user probably not familiar, some familiar, some unfamiliar with search interface. So we need to take all this into account when we organize metadata, when we design a data discovery system. So the objective of this interest group is to provide a forum for all interested in this topic to explore the shared issue, how we can together to improve data discoverability. And on top of that, we generate actionable recommendations for all stakeholders. You know, data discovery cannot resolve by repository alone. There are lots of stakeholders in this space. We need to work together to address that issue. And the way we organize the interest group activity, so we form a task force. Each task force take on the different perspective of data discovery. So we start the interest group with 4 task force. You know, the guideline for making data fundable. We collect the user case, what the challenges researchers in discover data. And one group about metadata enrichment and the relevance ranking of the data search system. So after the recommendations or output generated from the task force, a task force may close, then we start a new task force. So we start another new task force, research metadata schema. So that's basically provide recommendations for people, for repository publish structured data. In the report is more about structured data by using vocabulary from schema.org. So that make your data set more discoverable by web search engines. And we also had a task force called data granularity. They all spawn, when the task force identifies specific activities to carry on, they can move from task force to start a working group. For people probably not interested, not aware about RDA structure. So we started with interest group that talking about the general, topics. Interest group can generate output, but that output may not necessarily need adoption story. But if you have a specific task activity to do, you can move to the working group. Working group has a time frame, about 18 months, generate output. Usually that output need adoption story. So interest group can be there, discuss that topic actively as long as you want. That's why we have this interest group have been there a while. Okay, so in our recent output, as we said, is 10 principles to improve dataset discoverability. So later in this session, we will devote a big chunk of time to give to adoption use cases about that. And also start from plenary 23, the members would interested to see more discussion how the rise of AI impact on the data discoverability. So this pretty much activity we have been carrying on in last about 2 years. We organize a monthly meeting. If you go to the RDA website, find this interest group, you join the group, then you will get email notification, the monthly meeting, and what topic will be discussed in that month. Okay, so I hope that gave a broad view what we are doing. Yeah. So next we move on to the session agenda. Sorry, go back. So it's.
Did you get it?
I think I get it now. So, sorry. At each plenary and in monthly meeting, we also ask members what topic they want to hear more. And so in last plenary, we get this feedback from audience. They want to see other repository, how to implement this feature called a similar dataset recommendation. So I will give a brief introduction of that. So what is a similar dataset recommendation? It's like when you purchase things, you get a recommendation. Some other people also purchase this. And back in early stage of Google search engine, usually they have, at each search result, they have a link. Here is a similar page. So that's kind of we could use that similar approach to find a similar data set. The purpose is to provide users with alternative discovery paths to search for a data set that's relevant or similar to what they are viewing at the time. So just to give an example, this example is from the data access catalog of a research organization in Australia, CSIRO. You can see, this pointer doesn't work. You can see here is metadata record. At the bottom, it's recommended the relevant the data set. And here is an example from Pangaea when a user looking at this data set, here at the bottom, you also have a recommendation, say data sets with a similar metadata to the current data set, or say other users view this data set, also view other data set. This is this label here are clear why those data sets are recommended. One is based on similar metadata. One is on the cloud voting, for example. Here is an example from Research Data Australia. That's a service provided by ARDC. We used to have a similar data set search there, but it's not there anymore. So I use just put a mock-up. So if user views this data set, then here is a recommendation. So there are similar data set from the same project, from the same service provider, for example, and all these examples I talked so far is a recommended data set from within your repository. Of course, you can also recommend the data set, search result from external repository. For example, you can construct a query by using current title and some keywords from metadata, send to, say, dataset API, then you get a result back. But here today, we're talking about how you do the internal dataset recommendation, because that's the search parameters you can control. You cannot control external search API. You can just use what they provide. Okay, so that's the approach we at ARDC. I believe that's also Pangaea did for the recommended similar data set. So first we identify those attributes or criteria you can define similarity. For example, you can use a content and the metadata attribute as a similarity measure. You can use a title description and the keyword as a semantic match, and you can also use geospatial coverage. If you look at health data, probably in certain location, you also want to look at the climate or something, how that impact on people's health. Then, it depends. You trade off between topic similarity and the diversity. Okay, for that you need after your search result, similar data set is recommended, you need to test with user how that's being used. And you can use other relation. For example, here are the other data set from the same researchers of this data set, coming from same project or come from same ground, etc. And the behavior data, like Pangaea's. So other users also clicked on this. So what we did, we use each attribute as a query to measure other document similarity with the one to compare. Then come out the different score for each of these metrics. We normalize that. Then we combine the score. That comes again. It depends how, which attribute matters to your user, to your repository. You can weight each attribute, these criteria, similarity material differently. For example, if geographic is more important, you give, say, twice importance than other attribute. So after we normalized the combined the score, then the ranked, and you can combine all them, ranked as one set of recommended data set to the user, or you can treat them separately like the Pangaea did. So the design principle behind this approach is we use a hybrid recommendation model. So we use different, treat each similarity criteria differently, then combine them. That worked well than a single evidence-based, just a similarity-based, for example. And then, because this module, we can allow each recommendation, each similarity measure or recommendation to be developed, tested, and trained. And then we can use the both value. That's just as I said before, you can give each of these recommendations a different weight. Then you depends on purpose of your user or what you want to recommend. You can balance between relevance and diversity. And avoid over-representing data set from single source, for example. And of course, any of these need a continuous improvement. You have to keep look at the user's interaction log to see how that recommendation feature is being used. The reason I said that example from ARDC, we used to have there, but we don't have there anymore because our search log indicate that feature not used that often. So we direct that effort to somewhere else, somewhere the feature used often, so to improve that. Okay, so another reason, when I give this presentation, I look at quite a few repositories. I look at Zenodo, I look at a few repositories. I didn't see many of them implement this feature. Even you look at a Google web search today, that feature similar page is gone. There are several reasons for this. That's firstly, so the search ranking is increasingly using more and more parameters for the ranking, not like before. You just based on the for web search, you just based on the recommendation. This website linked to that website. So today there are probably thousands, 10,000 features used for ranking. So usually search result, the quantity has been improved a lot. And secondary, some of those features, for example, the geo coverage or other attribute used as a similarity measure, you can use. It could be function the same as the filters, facet search. So, and also moving forward, those embedded recommendations are more from AI tools. So, for example, I sent a query to the JetGPT. I said, find me data set on average rainfall in Australia. So I got a list, recommend me several data sets from several accountable repositories. So that's kind of recommendation, probably move into feature. Okay, I think that's I want to say about similar data sets recommendation. Any question? Claire? Claudia? Oh. Yeah.
Wonderful work. Oh, this is Claudia Medeiros from Brazil. Wonderful work. Yeah, I know, but I have to say where I'm from. Wonderful work, wonderful presentation. It's not clear to me how much of this has already been implemented and what is future work.
So this one, that's already implemented. That's for example, the Pangea example, they use a similar approach. We ARDC, we also use that approach. But from here, how much this be implemented by repository, probably I haven't seen examples, but that will be increasingly online. Okay. If you have any questions, you can type in the shared collaborative notes. Do we have people online? No. Yeah. If not, we can move on.
So, okay, the next two talks will be about the 10 principles, but just for all the people here that are not familiar with the 10 principles that we released last year as recommendations, I will give you a very, very short overview what we are talking about. Mingfang already told you that it was released, I think it was last summer, but there will be a paper coming soon with an even more shorter version of that. But the 10 principles as released last year is mostly, so we have principles, and for each principle we have different recommendations. So the first one is P1, know your user. This is about surveys, interviews, A/B testing, observation, what is done. So it's just monitor your user, what the user is doing. Then improve presence in web search. That's a very important thing that you should keep in mind when implementing a repository. So the recommendation, they are very, very detailed about keywords, embedded machine-readable metadata, and so on, though that's very important. The principle number 3 is be present in literature search and in user research communities. So that means there needs to be linkage between the data and also literature to get people from the literature to your data and the vice versa. You also need to make sure that people coming from other disciplines can use your repository. So there should be improvements in, though it's not only for your community, but also people from the outside should be able to use your repository, find data in it. So based on that, you don't need to be too community specific, but somehow allow also external people to easily find your data, and of course search engines out there like Google. Then you should support data search from broad to narrow terms, though that means if people are very, very specific, they should also find more general data sets and vice versa. So that's something by improving the metadata in your data sets. So P6 is managed duplication of metadata records. So you should, of course, avoid to have too many duplicates in the data repositories, in other data repositories. So people, when searching for data, only find a specific version of that data set. So for example, you also have to think of, if you have duplicates like different versions, how to rank those. Then the P7 is provide and link metadata at different granular levels. So some people just want to download a very, very large data set and not a very specific one, and it should be easy for them to get it in a specific granularity. But if somebody is really interested in a specific piece or just one measurement parameter, it should be possible to also search for those and download that. Then the principle number 8 is about consider users' metadata needs from the user's perspective. So you have to figure out how your users are searching and what actually they use as keywords, for example, for searching, how they formulate their queries. And the recommendation is also, for example, to use AI technologies to improve that. So P9 is, of course, we always have to say that improve your metadata quality, because that's the most important thing, that people find your data. And the principle number 10 is to enable linked data, which means you should use persistent identifiers, link it to everything. So for example, in the session before here, we had something, if you link research organization together in the affiliations, it's possible, for example, for a university to find out all the data sets that were funded by them, or something like that. So that's important to have enable these PIDs to get the linked data approach done correct. Yeah, so that's the 10 principles. And the first part is how we adopted them in Pangea. I'm coming from Pangea, which is a search repository. As you see here, when you go on the homepage, the first thing you see is a search engine, and you have an auto-completion. So that's basically our main entrance point is users are searching data, so we need our metadata correct. So just a very, very quick background. Pangea is part of the World Data Systems. We are something in between a generalist repository and a very specific repository, but in general, everything that has coordinates can be saved in Pangea. So we also have an editorial workflow, so all the data sets on our site are correctly annotated, harmonized and everything, so we have harmonized measurement parameters like that. So we are also Quadtrust Seal certified, and we are World Meteorological Organization data center. So that's just for about Pangea. So the recommendations you have seen before implemented by Pangea, or we looked after those, is mainly know your user. We have a check mark on it, we do that already. Improve the presence in web search, be present in literature search. I will show you the examples. Support disciplinary and interdisciplinary search, it's some work in progress because we are not a generalist repository, so it's different, so there's a lot of work for external people to get that. Support broad terms to narrow terms, I will show you an example how that works. Manage duplication is, if you're a harmonized data repository like we are, we don't have any duplicates. No, it's a joke, but we also have duplicates. Then search within data. I don't like the title of that recommendation too much, so it's more the different granularity levels that we have. User metadata needs metadata quality and include identifiers. So I will show you some examples. So for example, know your users. You have seen we have a search engine or a homepage, but actually Pangea uses Matomo to figure out what the users are doing on our site. And when we are checking out actually where the people are coming from, when they are landing on landing pages of data sets. So that means you have a DOI and there's a landing page, and we are just recording where do the people coming from when they're landing on the data page. We figure out that half of the users are direct entry, which means in our case that they are coming from our own search engine. So they are coming from inside our data, or they entered the URL directly, but that's unlikely for DOI, so they are coming from our own search engine, so half of the users. But you see here, for example, that the second one is followed by Google, so that means users are not necessarily going to the search engines of the repositories, they are just entering their keywords in Google. And so it's about 30% coming from Google, and then we have also direct websites, and if you look at that more specifically, sorry, it's a little bit small. So you see here 45% it's direct entry, as I said before. 33% is from search engines, but for example, from websites, it's 20.8%. And you see here, for example, this is coming from nature.com. So that means it's people coming from publication at Nature, like an article, and they are clicking a data citation there and coming to the landing page of the data set. So you see here, if you go back to those, it's if you compare the numbers here from the years, this is really growing, and actually the direct entry is going down here. So in 2023, there was more than half of the people coming, so it's going down. More people are coming from search engines or from publishers, but they don't use anymore the landing page of the data set, of the data repository itself. So maybe they're also coming from AI search engines, like said before. So that's clearly seen here, so it changes over the years. So we will see the search engines inside the repositories are no longer so relevant, and it's also with the recommendations. As we see, they are no longer so relevant because people are coming from other repositories, from other places in the internet, so they don't really search here. So you see here, Copernicus and Nature is, for Pangea, the most famous publishers where the people are coming from. Issues Pangea.de is our own issue tracking system, so this is an outlier here, but it comes from people submitting data. So, and then we have HU publications online. So that is one thing. They improved the presence in web search. Here's, for example, a landing page of a Pangea data set. And here you see, for example, also the other recommendation. We have links for all the authors, which is quite common nowadays. Every data repository should have those links to the authors. But actually, to be really readable by those external search engines, so you get more users coming from Google and from somewhere like Google Dataset Search, you should make machine-readable metadata embedded into your landing pages. So for Pangea, we implemented the improved presence in web search by having the whole metadata, everything you see on that web page, all the measurement parameters, everything is available as schema.org, so it's readable by the external search engines. And so it's also accessible by the AI in that kind. So it's very, very good for those users coming from the outside to actually find those data sets without going to the repository homepage. The other one is be present in literature search. So still nowadays, people are not searching for data directly. They are going to publications, in articles and so on. They want to find the data. So the most important thing is, yeah, the data sets, landing page, and the data set should be cited in articles, so people can come from the article, get to your data sets. So the most important thing is to have something like a copy citation link there, or download it as RIS or BibTeX, so people can easily insert it into their publication, because copy-pasting the link is not easy. So just allow the users directly click on a button and they have it in the clipboard to copy that. And the other thing is to make the inverse possible is to link data sets. So refer from your data sets to publications outside. So for example, this data set is a supplementary data set belonging to that publication here. So actually the link should be in both directions, but if you have it in one direction, it already helps. So I hope here, but anyways, if you have that, for example, that supplement to link, and it's also included into the data site metadata, then some services externally can query databases like Scholix to find all the data sets belonging to a publication. So that's one thing. So that makes it easy for that external to get you. The other thing is, which is my personal favorite about the whole talk, is the number 5, support data searches for from broad terms to narrower terms, and also support both disciplinary and interdisciplinary data searches, somehow related because it's using the same technologies. So for example, in Pangea, every measurement parameter, like you see here, a few of them, are linked to a vocabulary. In that case here, for example, it's worms, it's for marine species, so you can look up species names. And every measurement parameter is consisting of more than one term. Here, that example only consists of one term, which is a species name on taxon, on the worms taxon database, but there might be other examples. So, for example, that helps users if they're actually searching, for example, for a term here. In that case, it's rhinospira. It's also, we don't know what the rhinospira is. If you search for that in Pangea, you find data sets. But if you actually look at those data sets, you also see here those topic recommendations on the left-hand side. Like you see, it's zooplankton, so you have an idea, but stable isotopes. So if you look at the data set, you won't find the term rhinospira. But how does it come that it's a search result in that case? So if you look at that one in worms, this example from worms, you see here Rhinospira Ehrenberg 1845 is somehow an older name for something which was revised today, and actually the accepted name is a different one, it's Globigerina. So, but this example shows there could be people not searching for the official accepted name because they may be using older literature or whatever. It's just the example here is, of course, a little bit constructed, but basically So actually, the accepted name here is globigerina. So, and the interesting thing is, if you look at the first data set, or yeah, the first data set here, you see here, it's globigerina boloides is that measurement parameter. And you see here the taxon name, and if you look at that one, this is basically the same. But how does it work in our case? So actually, what we are doing here is when we are indexing that globigerina boloides, we are adding a lot of those terms you see here at the bottom. So all those search terms are also added to the full text search index in our catalog. So people looking for rotaliana, for example, will also find the data sets with a lower score in that case. So the exact matches are always preferred, but in that case you can find them. And the other idea here is we know because globigerina is zooplankton, we also have that information and can show that in the facets. So actually, what we're keeping in parallel to our main search index with just the parameter names, we have that linked vocabulary is somehow expanded to all those broader terms of that, and they are also put into the search index so you can search for that data set, which is quite nice to find that data set using a term like that one, which is not so commonly used. So. But of course, you can also do that with other stuff like locations. If somebody is searching for Pacific Ocean, the person might also want to search for data sets in the Hawaiian Sea or whatever, something like that, which is a narrower term of that. So the other one is search data within data. So this is about the granularity. So this is an example about a data set which is a child of a publication series. No, it's a data set bundled publication. So actually, if you have different levels of your data sets, you also want those people to find the broader data set. And so in our case, for example, if there are very specific measurement parameters in a single data set, you can push them up in the chain. So if somebody searches for a very specific parameter, this person will also get the parent data set, which is here sedimentarily, so this in notation here. So actually, we include the information from the child data sets into the parent, and on the other hand, depending on what the user needs, we have a slightly higher ranking for the parent data set, so the user doesn't get too many hits in the search results, so it get only, if it's a more common search query to get the higher one. So this is something where you can improve your dataset search so people can easily find their granularity that they want to have. And the last one is we are including the identifiers, so research organization identifiers, we are using the World WOMS marine identifiers, we are using IGSNs, ORCID of course, we have projects from OpenAIRE, and of course, we are linking with publications through DataCite DOI, DataCite Crossref, and other DOI providing repositories. So that's about Pangea, and now the next one is GESIS. Should? Yeah. Okay. Any question?
Just a quick one. Maybe I missed it.
Sorry, yeah. So we were asked that you give your name.
Name
Yeah.
My name is Kagiso Mabe from South Africa, Johannesburg. So just a quick one. I don't know if I missed it, but in terms of the reuse, say I want to use a data set for not commercial purposes per se, but to use it on a public platform.
Yeah.
Are there any limitations to that?
It depends on the data set, so you have to look at the license. So in the screenshots, each data set has a specific license. So if it was not in the screenshots, but if you scroll down, there will be the license. But in Pangea, most of the data sets are CC BY, sometimes a little bit more restrictive. So in general, we don't have any never have the non-commercial tag on it. So also for commercial use, it's allowed. But there might be outliers on that one. But in general, you have to check the data set.
Thanks. Can I ask a question? So, since early this year, our data catalog, the large amount of increase of traffic, the Google Analytics shows, say, your user number, the active user number is like the figure. We don't believe that's all human activity. So the AI tools nowadays hunting for data to train their model. So you mentioned you use Matomo, to track user activity. Can that tool differentiate human user and a machine user?
In the past, yes, but nowadays it doesn't work anymore. So we are also looking at that stuff. So Matomo was working very well in the past because actually Matomo and also Google Analytics is using JavaScript, so it actually has to be displayed in a browser to be tracked as a real human user, while something like a normal robot would just download the HTTP request and then scan the page, but never ever execute JavaScript. But this changed a little bit, and I have shown numbers from 2024 because this year in 2025, we see a lot of headless browsers now, remote controlled, that are just looking at your web pages and they fully execute those. So actually the Matomo numbers this year raised a lot, but if you look at those, there are two specific countries which have a very, very high, one country is not far away from here, the other one also not far away from here, have a very, very high hit, but you can theoretically detect those because in most cases they are only shown 1 and 2 pages and then end the session and they are not coming from a search engine. But it's a problem. It's not easy to figure out. We know that.
So we see similar patterns between repositories. So, hand over to...
Yeah, thank you. Okay, so another search engine for data. I'm sorry, it's very dense right now. Also from Germany, but this is about social science, not earth science. Most of the data that we have are surveys, and also these are, I would say they're very high quality because we don't have a lot of them. We put a lot of effort into curating and adding metadata and documentation. On the other hand, so as you can see, there are about 7,500 data sets, but of course all these data sets come with different variables, and then we are at about 1 million. We also have other entity types, for example, standardized instruments and so on and so forth, just to get a bit of idea about what GESIS is about. Right, so what do we do with the principles? So one thing that we really started doing is that we did some user studies, 2 observation studies in particular that were quite intensive. We actually looked researchers over the shoulder, and it was actually quite surprising as to what they did, because the way that we usually tend to think about them is, well, they are here and then they put something in, but we found that there's a whole process that happens before they even get to our website and put something into our search engine. That was quite interesting. And this is also something why we think that web search and literature are so important, because this is really like how we get the people. So we did one big observation study in 2021, and recently we started to expand that to figure out how people find data with AI, which is very, very new, and it's actually quite different, because we found that some of our systems that are, whoops, I'm destroying the hardware, I'm sorry. There we go. Okay. Okay, so percussion. Yeah, so this has been quite interesting, because we found that there are huge differences in, depending on which product people use. ChatGPT is different than Claude or Gemini, and they all seem to have a very different idea as to what our data actually is and what is inside the data. And also, the different versions are also very different. So this is something that we're now looking into, on how we can standardize it, and what are the different, like, why are certain data sets that we have well represented and others are not. I can't give you the solution to that problem yet. We're working on it, but I just have to point out that it is an interesting problem. Right, and the other one that we started working on around the 2000s is to understand how people find us via web search. It's mostly so we are Europe-centric. That's mostly Google, although the numbers for Bing would look quite similar. And what we have really been trying to do is to increase our visibility indexes. This is something that's collected via a tool called Systrix. And then what they basically measure is how well you compare to Google Ads. And so we have been doing quite well. And then and this is what I really like, because we stopped the project around here. And that's a very good reason for leadership to give us more money. Although it is a bit of a coincidence because of other factors. But yeah, it's, as you can see, it is an ongoing task, because web always changes. Different things are relevant at different times. Mobile usability used to be a big factor. It's not so much anymore, and so on and so forth. So this is something that we basically do, maybe not every day, but as an ongoing thing. Then literature search. One of the things that we really started doing is to, well, first of all, the same thing Uwe just said, it's super important that you provide citation links so people can put them into the papers. But we also collect what kind of publications are citing our data sets. So this is an example, and then we would show that under the linked information. And you can click on it and say like, oh, okay, there are 2 publications here, that's nice. Then we really started to support interdisciplinary data search, mostly by trying to push our metadata into the world and making people aware, like, oh, by the way, we do have that stuff, and you can now find it via OpenAir and basically anyone who's interested. And also via signposting and so forth. So a lot of interoperability work there. And then I skipped 2 principles, because we're not really working much with that. And jump to principle number 7, which is different granularities levels. As you can see, we also link the variables that are inside the data set. So variables in social science is usually how different people answered a particular question. And we often have requests, like when we think about what people are trying to find, not in terms of, oh, I'm trying to find this data set, but in terms of what are they trying to add to their research. It is usually that they have a question like, okay, in Germany, how many people in this particular year had this opinion towards this politician, for example? And what they're really, so what's really relevant for them often in this whole big data set is just this one variable that talks about this particular politician. And so we've found it really useful to add that as a variable. But interestingly enough, when we try to convince Google to index 1 million variables, they were like, no, I don't think that's relevant. And and now we're really picky about, so we actually forbid most of the variables to be directly findable with web search, because it's it has led to Google also ignoring some of our other content, and that was not, and that was when we pulled the plug on that. Actually what we learned is that if you want to be findable with Google, you have to be kind of picky about what you ask them to index. That's the lesson there. Right. And then talking about the metadata, I kind of like hinted at that we did some very thorough studies about what people are actually looking for. Like really from first principles, like you observe a researcher trying to find relevant bit of data for their research. We're very careful not to tell them what data they're supposed to be looking for, because then you get actually really, really different results. Instead, we try to really ask them, like, okay, like for your current project, maybe you want to have additional data, how would you go about that? And then you get very good combination of, oh, I'm going to place a phone call with my colleague and ask him about what kind of data I should be using, and just, you know, like typing away on ChatGPT or whatever strategy they're using. While when you ask them for a hypothetical, strategies tend to be quite different. Like well, obviously they won't, you know, ask a colleague because they don't know any colleagues in this arena, and second of all, it's a hypothetical, so they're not really that invested. So that's one of the main things that we found, is that it's actually not totally trivial to get people to tell you what they really want and why they want it. But yeah, we put a lot of effort into trying to find it out and then trying to tailor our systems towards that. Yeah, and then let's talk about the other side of AI. And that is that we are using AI to identify links, especially when it comes to publications. So we download a lot of publications and go through them with AI to identify which data sets they might be referring to. And then we use knowledge graphs, which have the added benefit that, of course, you can link everything with PIDs. So it's like one principle, two principles in one. And then bring that back to the actual search engine. So we have like a hybrid approach. We put everything into the search engine, then we take it out to be a knowledge graph, then we do the linking enrichment, yeah, and then we play everything back, or you can also use a Sparkle endpoint or EPMH to download all this information. So this is the principles that we've been looking for, and I think that's my last slide. Oh, now it's back to the agenda. So any particular questions about what we were doing to work with the principles? So Mingfang, you want to ask me again what I do about AI bots clogging us the systems? Yeah, okay. It's a pain. It really is. Well, for us, not so much, because we use we don't use Matomo. We do use different tools, which are actually very good at filtering these sorts of things out. But unfortunately, yes, there were instances where the search engine basically slowed down to crawl, and then we had to manually block certain people trying to, and it just produced so much more work for everyone involved. But generally speaking, we are lucky in that we had accidentally had from the very beginning a system that was relatively well suited to identify which were the offending parties, and just to be able to block them quite efficiently. So that's what happened there. But I do know, I'm a lot, like talking to other people who are also in the field of running these sorts of search engines, and it's a pest right now. It's a huge problem. Like, everybody is suffering, and so much, so much energy and effort and money that could be going to making better search for everyone now goes into trying to keep these people away, and I think it's a bit of a problem. But anyway.
But in the end, even this use AI, in the end, we still landing to the repository to download or access data. Just another way, another pathway to search for data sets.
Now, I don't know. I don't see right now that this is actually what's happening, because, for example, if you look at, so the one thing that we evaluated a bit more was how ChatGPT finds out data, which is actually right now working very well. And part of it is that it already has the information in the base model, which is of course nice. But when they look up additional information on the web, they don't actually go into the database pages, but they go into the normal web pages, which are usually available via technical explanation. It's not so bad, but it's the real problems are people who are downloading over and over and over and over again all the metadata, and that's a real issue. I don't mind that ChatGPT comes by once a month or whatever, or even whenever someone asks questions about that. That's not the issue. It's really the people who are just, I don't know, they don't have a stop button.
I think it's also not necessarily AI bots. I think most people call them like that. The idea behind that is now with the techniques you can book a lot of in some data centers in somewhere in East Asia. You can book a lot of, and then you are running just browsers. Normally you can run browsers that identify them as so-called headless browsers, so you could differentiate them. But nowadays, those browsers are really running with this headless flag turned off, and the reason for that is just to grab that stuff and looking like a real user, but actually because you have so many requests from the same IP address, it cannot be a real user. But actually the idea behind that is to steal that data somehow and suck it in and process it. I'm not sure if this is really all AI bots. I think it's much more just getting all that stuff and appear like a browser to the repository. That's the idea, so you don't have to check robots.txt or whatever. They just do like a browser clicking links all the time. That's basically what they are doing.
And we had bots before that. I mean, Internet Archive, for example, looks at our stuff quite regularly, but they do it the right way, and it's not an issue at all. Like, this is not us being like, oh my god. We do have also like a lot of actual users. That's also not the issue. It's really a very specific people who are apparently doing that. Right. So, group discussion?
Yep.
One question. Okay.
I think
one
two more questions.
You can load the
In the meantime, I'm loading.
Claudia, name and organization.
Okay, I'm sorry. I'm Claudia Medeiros from the University of Campinas, Brazil. And your 10 principles are wonderful, but I wonder how many people you need in your infrastructure to ensure that they are enforced. So just to extend, in my university now, we have about 2,000 people depositing different kinds of data from all kinds of fields. How many people would we need to have these principles enforced so as not to overburden the researchers who are depositing the data?
So I can speak for Giesen. I was just trying to get a rough estimate. So we have one full-time developer who does, basically keeps the system itself running, who's not, doing any additional stuff. There's me, and well, most of my job is, giving talks, so I'm not that useful. But we have another PhD student who does, 50% maintenance and 50% working on these topics. Plus, we have another senior scientist who's also doing like part-time user studies, as we can pull them together. So I don't think it is more often. So I think the big hurdle is to get started. Like once you have that set up, that this is something that you're doing as part of your normal running the system, and I mean, obviously, we're co-chairs of the group. We don't even do all the principles. We're skipping on a couple of them that we're not too familiar with. But once you get going, you find that keeping up these sorts of activities is not that hard. The real trick at the beginning is to get to a point where you can actually productively do something, and then the upkeep of that is not that labor intensive, really. So that would be my impression. I don't know. You want to answer that question as well?
I think most of stuff, as she said, you need to get started at some point, and then once you have set it up, it works mostly. You know how to do it for your repository, how to feed. once you have implemented schema.org, for example, in your repository, you know all the search engines are doing well in that case, and you don't need to carefully, but then there are other things, and you can also ask other repositories how they do it, because, for example, like feeding too much to Google is also a bad idea, so that's somehow you keep in mind, but in general, setting it up, it's not too hard.
Kia ora. Naraka Nepara is my name. I am from Whakatane, New Zealand. So I have a question. It's probably backdated, a little bit different, around the recommendation model that you're structuring. So you're using a tracking device, tracking whatever tool to get there. Once they've got there, you've got the data. Have you got anything that's tracking them on the recommendations and the bounce rate once they go on there? Because I wanted to know if those recommendations were good, because they're not good on Netflix.
Well, I'm the only one with a microphone right now. I'm the only one who doesn't do. So Mingfang, you want to take that?
So your question is how to track that data?
Yeah, so we have it so that we're able to give them recommendations, like Netflix or whatever, right?
Oh, right. Mm.
Do we track bounce rate when they hit that recommendation and they go, oh, that's not right?
Yeah, so that's on the similarity data set recommendation. At the end, we need to monitor how user to use that feature. So, for example, does the user use the click on the similar data set at all? Or if they click on the similar data set, you know, how much time they spend to view that data set, or even better, lead to access that data set. So we use not just the Google Analytics, we use our internal logging system and analyze those events. And Google Analytics is very high level, you know, does not give you that level of detail. Thank you.
Yeah. So actually, it's the same for Pangea, more or less. So you have to track. So at least with Matomo, we are also recording what the people are doing, if they're clicking more on the similar data sets or the related, or the users who have downloaded that also downloaded that thing. So actually, this works, and of course, if you get more hits on those data sets, it's good, but it's still very hard to track that. Yeah. But for example, in our case, people are still using that recommended data sets quite often. Because especially it's important for those people, that's interesting, because we said we have a lot of more entries from search engines like Google. So Google, people are entering some stuff in Google, they land on a data set on our site, and when they then can go to similar data sets, it's easier for them to go to the homepage and start a new search. So in that case, so the feature is still very, very often used, but you need to somehow track it. But similar data sets, as usual, which are really similar in case of geographical distance, is quite often used.
So just on top of that, set log analysis of user interaction, not just for that feature, similar data set feature. In our recommendation, we recommend a set of tools you can to track user activities, either through log, you know, what's your top searched query, you know, if that query result 0 result or 0 click, you have to go back to look at what is your search quality in that. And also, the search log, you know, shows the behavior, but it does not tell you what the challenges they encounter your website, so you can run other user studies. So yeah, so read the recommendation. If happy to contact us if there are any questions. I guess we talk enough talk from us, so we would like to hear what kind of data discovery challenges you know, either you are repository managers or you work with researchers or you search data yourself, what kind of challenges you encounter, you think that's, should be take into account?
Of course, enter it into the discussion.
We can
Topics?
have one person talk at the same time, other people, you can type in same time in the collaborative notes. Sorry.
Okay,
Yeah.
thank you. So from the other side where we conduct research, some of the major challenges we face when you're trying to discover data and of course implement FAIR principles is that there is either poorly enforced data protection laws or they are underserving data protection laws. And some of the landscape analysis and access to data in African settings, because that is what I've actually done. Some of the researchers share data with you and it is clinical or hospital data. And this data has all the details, including phone numbers, including name of the patient and such. And so I would love to know, first to put it there, but also to know what you're doing to improve the way we enforce our data protection laws in African settings.
So I recently talked to one of the people who do the ingest for us, and even in Germany, which is, I would say, hyper-vigilant when it comes to privacy. Almost all of the data sets that we receive are not properly anonymized. And so one of the main tasks that we have is to, tell people like, no, you can't publish that. Not even under, not even with an asterisk or anything like that. Because a lot of people are just not aware about that. So, and this also oftentimes, unfortunately, leads to rejection. Like we cannot publish certain data that were, for example, collected under unethical standards, which is sometimes very unfortunate because it's valuable data, but there are ethical concerns and people who are doing, and I don't mean like people were tortured or anything, but I mean like people were asked questions without proper consent or anything like that. So it's a bit of a mess, but. Well, we always hope that all the training that we try to give people will in the end pay out, that there will be fewer of these problems. But so far, that hasn't happened yet. Right, and you also...
That's great input from... Yeah, that's good.
There are too many results. Yeah, this is... This is a granularity problem. Like back when we had only 5,000 data sets, nobody complained of too many results. And now that we have 1 million variables, everybody's like, oh, I can't find anything. It's too much. Yeah.
So it's Graham Parton from UK Centre for Environmental Data Analysis. I put my question up there, actually. So part of it is, if you've got these similarity data sets, discovery pathways, are you just reinforcing what's going on there? Yeah. And instead, one of my colleagues sort of came up with the idea, you rummage around in a handbag to kind of pull up something random. Do we need that sort of functionality as well? So you can get those odd data sets which don't get much use, but actually really relevant.
Yeah. So actually, this sounds like if you're feeding the AI by the AI output of another AI, it gets worse and worse. Yeah. Basically, yes. So theoretically, if you have a search engine, you could do something like that. Like, for example, if you're buying something at Amazon, they also want to get rid of the not so often used stuff, so they sometimes pop it up. So theoretically, I think you could do something like that in a search engine. But actually, the problem is scientists are working a little bit different than Amazon buyers, so you have to be a little bit careful with that. So maybe there should be another list of not so recommended data sets with a better name or something like that.
So when we implement that similar data set recommendation, we remove that data set in the first page of search result. Because search results are matched to the query, not matched to the data set is viewing. So there are different kind of algorithm similarity match there. Yeah.
So we actually did ask people if we should do that, and all the researchers were like, oh my God, no, because they really, because most of the time what they're looking for is the most cited data set. And we cannot really provide that, but we can kind of like provide a proxy to that. And so unfortunately we are very filter bubbly in that regard. We have tried to really try to enforce this long tail data that doesn't get downloaded that much, because we do know that from time to time it does get downloaded. Like we have so few data sets that actually every single data set is usually downloaded at least once a year. So around about, not you know, but roughly in that direction. And so we try to promote these, which is also why, although theoretically some of the variables from some of the more popular data sets have a higher likelihood of being relevant than some of the less used data sets, we actually prefer the less used data sets over the common variables, which was actually quite a bit of discussion, but yeah. That's
probably a challenge for Ui. Look at your Pangea search log to see how often that feature is used. Report back next plenary.
So multidisciplinary, multi-language data, any metadata term vocabularies. Yeah, that is an issue. We do some trickery by doing query expansions. Basically, whenever there's a word that we know, we also include all the other words that we happen to know are translations or that belong to the same vocabulary. But I would say it could work better.
Yeah, actually, that's basically going the similar direction like that with broader terms and narrower terms. So if you have a terminology, you can help with that. But the problem is you need a terminology which is somehow very, very broad. And the problem is in the scientific use cases, most terminologies are very, very specific. And so they are actually missing that multidisciplinary and multi-language stuff there. So currently, for example, in Germany, in the NFDI, Nationale Forschungsdateninfrastruktur, we are trying to develop terminologies which are a little bit more broad. But in general, to enrich your search engine, you need to add all those relevant terms also to your data sets, metadata. So it's get discoverable by all of those other terms.
Okay, so I saw someone typing in data is inscrutable as to what it makes discoverable. Yes and no. Like on the one hand, you cannot be sure. On the other hand, if you download Google Search Console, you get a pretty good idea why. It still doesn't tell you the recipe on how to make it searchable. But there's a whole cottage industry of consultants that will tell you exactly how to do it. We have kind of done some research on how to do that, and the main bottleneck that I find is that it's very dangerous to have too many pages that are very similar, because then Google basically thinks you're more or less a click farm, which is, of course, also not completely wrong. There are some ways with sitemaps and so on to at least try to direct Google in certain directions. Like, okay, we'd rather you would index this rather than that. So that's one thing. And then there was another one that I wanted to comment on quite quickly. Users presuming that there's no other relevant data set and they do not need to revise their searches. There's nothing on the first hit. So one really interesting thing that we found when people are using chatbots like ChatGPT is that the queries that you basically could not answer with Google are suddenly possible. Like really complicated stuff like, oh, I am looking for information on where people die on bicycle accidents, right? And then ChatGPT tells you like, well, there's like 3 data sets all over the world from these different data sources, and you can go and then you can cross-link this with other information and so on and so forth. And that is actually very, very cool because there was never something that could do that. And also, when people are using these chatbots, they really also have a lot of follow-up questions. And unfortunately, the way that it's currently set up, at some point it just starts to hallucinate. This happened to myself. Like I was looking for a data set, and I think I spent 20 minutes discussing with ChatGPT over a hallucinated data set that didn't even exist. So this is, I think, why it's so important that we try to get our data into these systems and also with high quality so that people are not led on these, wild goose chases and actually discover the data that is there, because there is a lot of data out there. Right. So what was the second topic? There were also some...
Yep. Did your organization, repository or catalog apply any of the 10 principles? Where do you see most success and challenges? So we just want to get the information. Have you already started implementing those 10 principles? And we have some answers here already. Yes, have schema.org already implemented.
That's very good.
It's a stack catalog. Now looking at GeoCroissant for marking up for ML discovery. Also have LLM-based search being implemented. Indirectly, yes. Without being aware of the rules. Okay, so DOIs, data citation standards, multiple links for entries. Okay, schema.org was implemented, so I think this is also very important. I think not only for data repositories, everybody should implement that at some point.
And it does improve your page rank, so...
Yeah.
Yeah.
And
if for no other reason.
Yeah. And the rise of AI tools to enrich metadata. And then I think that's also said in the next topic.
Yep.
Next question. Yeah.
What other data discovery activities have been or are carried out at your organization? What has worked or not? So there's something we try to create data articles, photo pages, and project pages that link back to data pages.
That has, like in our empirical studies, that has a huge impact, which is now something that we do for all our premium data sets. Also, what is very, very useful is when some people use it in teaching, because teaching is at universities, and if you have a professor who puts, data set links on their suggested reading list, that makes a huge, huge impact to page rank for that particular data set. That's a very good thing. And also, like, if you have a Wikipedia page for your data set, that's also huge. But it's actually not that easy to get through the editors by just, the second that you try to make 1 million data set pages, they will very, very quickly shut that down.
Okay, so topic 4, is that from Graham as well? No, who else did that?
So LLM primer, so who wrote that? That's super interesting. Can we chat?
Yeah.
Hi, Eric Laurie from the Australian Institute of Marine Science. We've just started trying to trial different ways of documenting data sets, with the goal being that not relying necessarily on the large language models indexing everything, but if someone does discover the data set, that then there is an explicit primer which explains the data set and cross-links everything, so that then you can either paste it into your chat session, or if they pull it down into the training, that then that documentation written in Markdown is optimized to train the LLMs about the data set. And that way it's answering questions which you wouldn't normally put in metadata, but hopefully then when someone asks weird questions, that it can put stuff together better.
That's a very cool idea. So one of the things that we've been toying with, and also again, no results yet, is to publish our data sets on Reddit, because apparently that's one of the big data sources for LLMs. And there are some subreddits that are quite serious. Not all of it is about movies and video games. And so we were thinking about, again, mostly for our premium data sets, to have like, ask me anything on specific data sets. Yeah. So, someone over there.
AI metadata recommendations at point of entry. So,
yeah, so this is...
It's from you?
No.
Okay. No,
So this is also something that we found is that even if people are using, for example, ChatGPT to find a data set, at some point they will go to the catalog and click the download link. It's inevitable because if you want to work with it, you have to download it, and so they will go to the catalog, yeah.
I just wanted to add a comment. I will give my name, don't worry. I need to place it first. Comment to the link to the LLMs. Jeremy Frey from the University of Southampton, UK. There's a protocol, Model Context Protocol, MCP, which is what is now used to link any LLM to any function you want it to do. So many people are indeed creating those to link a data set, so it will then go into the database. So currently most of them will know that the data is in a database and will tell you what to do to get it, but if you have the MCP in place, and you can probably copy them now, many of you, it will actually go away and pull it out.
Okay.
Whether it does the suitable things with it when it does so will depend on the quality of your metadata descriptions in there.
Yep.
Thank you.
All right, anything else that we have here?
Yeah, number 5. What possible new task forces would you like us to launch in the next few months? So we are looking for any topic which is discovery related that you're interested in. So we already discussed a little bit about AI, but we are still open for anything that you are really interested in. So just add it here as a notes. If you don't have any idea, you can still add them afterwards. So, and the last one is, what topics would you like to discuss for this group's next plenary session? Any volunteers for presentation or leading? So for the next one is a virtual one, RDA, which is in spring next week. And if you would like to have a lightning presentation, you could just talk to us or enter it here. Oh, are bots real users? Yeah, that's an interesting question. Yeah. So, yeah, maybe, yeah.
Yeah, they're the bots that you like and the bots that you don't like. And
exactly.
And the distinguishing between those two is it's difficult. I probably we have at some point blocked genuinely interested people. I'm sorry. But most of the time, as long as people keep to the recommendations for harvesting, like don't do it more often than once a month, try to not do all the requests at once, etc., etc. I think it's fine. It's just that when your system goes down periodically every time at noon for an hour, then it's not fun.
Okay, we have 2 minutes left.
We are actually perfectly. We have 30 more seconds, which I would like to thank all the people who have stayed. Yeah. Thank you very much. If you'd like to join the group, please contact us or just join the group. It's on the RDA website. And if you have any other questions, we will be staying here for a bit, and otherwise, feel free to go for, is it dinner? Or is it coffee? No. Yeah, anyway.
It's poster session now.
Brigitte offer dinner.